Hello, everybody. Good afternoon, or perhaps good morning, wherever you are. Welcome to the 7th free webinar of our 2021 Smart Building series. I'm very happy that you can all join us today. And we are discussing a great topic today. Why should I adopt a digital twin? And I'm very happy to be joined by Sébastien Coulon, who is co-founder of Spinalcom. And I'll be asking him to introduce himself in a minute. And we're going to be discussing this OT-IT convergence challenge of moving from automated buildings to digital buildings and how digital twins supports the real estate value chain. So I think a very interesting topic today, very worthwhile, because it cuts over a lot of issues around smart buildings. So, of course, we're very happy to take questions. The way that we've set it up today is Sébastien is going to give us a presentation, and we can take the questions later in the Q&A section of the webinar. So I would encourage you just to type in your questions into the Q&A box, which you'll find the bottom right of your screen. I'll be able to read those, and then we'll be able to discuss them with Sébastien after his presentation. Other than that, just to let you know that we are recording it, and you will get a link to that recording, which will be published, or you should get it by email tomorrow. And also the recording will be up on our website tomorrow as well. So you can check in and please share it with colleagues or contacts. That would be great. So let's get started. Sébastien, welcome to the Smart Building series.
Thank you, James, and thank you everyone for joining this this webinar. So just a word about myself. So I'm Sébastien Coulon, and I've got a 25 years experience in the IT industry, and I've spent my last 5 years focusing on the digital twin applied to the operation and maintenance phase of the built world. A short introduction about Spinalcom, and then let's move to the topic of today. Spinalcom is a software vendor. We are doing data management with our products. The objective is to enable decision makers to make data-driven decisions with the data we are providing, but not only, but also drive systems in real time. That could generate maintenance savings, energy savings, but also generate new revenue is something that obviously we don't talk too much so far. And also to truly transform the user experience by creating connected experience between different data silos of the building. So let's move to our topic of today, why adopt a digital twin? I think the first message I want to deliver here is that smart building expectations on the market are not met today. We have a very strong experience in France, but also in other countries like Canada, and we can see that many buildings that are delivered doesn't deliver the services that we're supposed to be delivered. And obviously, if we think about owners, what they want, they just don't want a smart building. What they want is an asset that will enable them to save time. So when they need an information, it's easy for them to find it. They don't spend hours to find it. They want to save money, obviously. That is an easy one. The question is, how can they really save money? And they want to increase their revenue like any company. On the other side, you have the different operators of a building. On their side, they want to save usually energy, space, better utilization of space. They want to save maintenance. And the two of them wants to improve attractiveness of their buildings, and that's why we see so many tenant experience applications coming on the market on this subject. So I believe today that smart building expectations of this type are not met. And there is a good reason for that, is that we need to move from smart building to digital building. So let me tell you a bit more about what I mean by digital building. So if you go back in the past, we can see that the smart building definition has evolved already. At the start of this smart journey, the buildings were analog buildings, and so automated. The most well-known is, of course, silo is the BMS system in the building. And then we move to smart. So what it means, OEM vendors provided equipments running on IP. IP network came into the buildings. And so we have been able to connect those systems to the cloud and analytic systems and so on. But that's not what the customer wants. What they want is a building that delivers services, not just a building that is connected to a cloud with some analytic systems that run and deliver poor value from our point of view today. So the definition has evolved from a building with a lot of devices generating data for only one application. So room controller generating data for the BMS supervision, for instance, to a building as a service requiring inter-system interoperability and data conversions in order to achieve the goals that I've just mentioned in the slide, in the prior slide. Okay. So now, if we want to move to this digital building, we need to fix one challenge. We need to make two different worlds to interconnect. And that's what the industry name OT-IT convergence. So what is OT and what is IT? Let's give a definition here. OT means operational technologies. It represents the physical world. Information technologies is anything that is digital. So any application, like a tenant experience app, like a maintenance system, like a CMMS, analytics, AI, booking a space, and so on, is IT. When OT is the BMS, the safety system, security systems, all the IoT that you're going to install in the building. So those two buckets, if I can say, are not the same ones. They are very, very different. And the first difference is that they are not running on the same timestamp. Seems to be easy stuff. But when you have a system on the OT side that runs in real time, and the IT side is not real time, you have already a big issue to fix here. But that's not the only one. Let's move to the next one. Let's talk about semantic interoperability challenge. If I want to connect different silos together, and not just OT to IT, but also OT to OT or IT to IT, you're going to have to fix the semantic issue that we have in buildings. As you may know, each system in the building is installed with its own referential, meaning building description. I'm not going to name the same way the floors, the rooms, the equipments, and so on in each of the silos. So it's what you get in terms of information when you get data from a silo is represented here on the right of side by the first image with the without word. This is what you get. And obviously, you're going to have a lot of difficulties to understand this. If you add semantic to the data, you're going to understand what it means. And here you're going to discover that it's a flower bucket. Okay, I think that is the perfect image to make understand the value of semantic in our world, the building world, but the same issue exists in other industries. Another point is that you will need to create connectors between the different silos, OT to OT silos, OT to IT, and IT to IT, obviously. Notably, if you need to cross the data for cross analytics or connected experience between those different silos. That's where you need to implement normally a unique referential in order to reduce the time you spend in developing all those connectors and have the different silos to understand each other. That being said about the semantic issue, you have another challenge that is the problem of having too many connectors to connect the different silos together. On the left-hand side, you have an example that is what we name in IT a spaghettiware. I guess you know what is spaghetti. So can you imagine this type of architecture? So what does it mean? It means that you have more connectors with that type of architecture. So you will have to manage more connectors developments, more connectors maintenance, updates. You will have to manage much more building descriptions. Each silo has its own building description. When you want to use data coming from 5 different silos in order to make a cross analysis, for instance, you will need to learn 5 languages, and so on and so on. So at the end, you get something that is very complex to implement, that brings a lot of issues, that usually doesn't run correctly, and at a very high cost. The solution is something that is very well known in the IT industry, that is named middleware. You need to implement a middleware architecture to make IT to IT, OT to OT, or IT to OT to interconnect, share data. Okay. That means that you will have less connectors. You will have just one building description to update. You have only one universal language to learn, the one of the middleware. So that is great. If you need one information, whatever which silo can bring it to you, you will ask the question always with the same language. And that, of course, is going to reduce the cost of your analytics developments, of your application integration, and so on. Additionally, with the middleware, you're going to be able to make connected experience between the different silos. Let me give you a very quick example here. And that is a true story. A customer said, we want meeting rooms to be productive. We say, okay, but what does it mean? He said that when it comes to a meeting room, of course, he has to book it. He has to make sure that nobody is going to be in the meeting room at the same time. So he needs to book it. He wants a good temperature in it. He wants the audio video of the room to be running correctly. And he doesn't want the maintenance guy to be there at the same time that he has booked the meeting. Okay, so it means here that you need to connect 4 different silos in order to deliver this value that is defined as productive meeting rooms. And so it means that you need to get the data from all those different systems at the same time, orchestrate in real time the different events in order to deliver the value. You can only do that with a middleware approach. Regarding the data ontology, there is here a table that is going to make you understand what it means and how it works for the ones that are not too much aware on this point. On the natural language, when I get an information, I'm going to add contextualization to this information. So if I look at a building and at a specific room of the building, I will know that looking at the temperature of this room, it is 21 degrees. I know that the room is 202. I know that the room is located on the 2nd floor. And I know also that the room is on the north side of the building. Okay, so in our natural language, we're bringing a lot of different information to contextualize this information. When the OT systems have a very poor ontology, they are going to give you a value and a sense of this value. So like 21 temperature, so like 21 degrees here in Europe, for instance. That is very poor because you don't even know where is that data coming from. So at the end, it's very complex to digitalize from this type of data. So what happened on the market is that people came with a very great idea, that is, we're going to tag the endpoints. So I can add information on it. And I will add the fact that it's on the 2nd floor, it's coming from room 202, and it is and this room is on the north side of the building. And obviously that really help because it can be read by humans, but it can be also read by computers. And so you can start digitalize from this. But there is a but here, is that there is no links between the data. So I don't know if the room 202 is close to, is between 201 and 203, or if 202 is close to 204 and 200. I don't know that. And so the links between the data is going to bring additional value, things that we do, human, I mean, automatically, okay? So that's why the market needs to move to a digital twin language. A digital twin language is a graph, okay? I've tried to represent that here. So what is a graph? A graph is made of data and links between the data. So here I can represent an asset like a building. The first point is the building. The second type of points are the floors. The third, the rooms, and then the device in the room, and then the endpoints that are linked to the device. And that complete ontology will enable to deliver much more value than a tagging language, because you have the links between the data. And in IT, we say that the links between the data are as much as important as the data, sorry, okay? And to enable this graph to happen, to be generated, we use the BIM for that, because the BIM is a graph that gives you all information about the building. It gives you the floors, it gives you the rooms. If you put the device into it, it gives you the device. And then you can add to the device attributes that are going to represent the endpoints. And so you have a complete and a full ontology thanks to the BIM. And this ontology, of course, can be executed by computers, analytic systems, and AI systems, of course. Now that I've reintroduced the digital twin concept, I would like to say a word about the fact that there is a lot of definition of digital twins on the market. And that's normal because you have different level of digital twin. And you have to take into consideration the type of digital twin that you need. And in the building industry, what we need is a multi-system digital twin. So the last step, because a building is made not just of one system, but of several systems that needs to run all together. Okay, I've got a BMS, I've got a safety system, I've got audio video, I've got IoT for some stuff, I've got a CMMS, I've got a tenant experience app, and so on and so on and so on. So it's a multiple system digital team that you need, and not just a system, process, or product digital twin. And that is very important to take into consideration when thinking about how digital twin can transform the building as a service platform. So let's dig into a bit more what we mean by multi-system digital twin. In fact, it's a data integration platform. So it's a kind of middleware, but with some specific insight. So the multi-system digital twin must be able to consume 3 types of data. The OT data we have talked about, the IT data also, but also BIM data, or if it's not BIM, a description of the building, and notably a spatial description of the building, because if not, I don't know what I'm talking about. And this digital twin engine must consume this data in order to enable the mapping of the data, so that I know exactly that the 21 degrees I was talking about is coming from this room that is on the north face of the building, and so on and so on and so on. Then the other piece of a digital twin of this type is that it must provide the data through a universal language, so that you don't need to learn 10, 20 different languages. And then we think, that's not a rule here, but on our side, we think that another piece of the digital twin is cybersecurity. Customer must be able to control the data coming in or coming out of the digital twin. And then the last piece of the digital twin is the data visualization. But that is only the last piece, okay? It's like an iceberg. What you can see is only a small piece. What is key is under the sea, okay? Digital twin is exactly the same. So data visualization, of course, it can be 3D data visualization, because here in this type of digital twin, one type of data that is integrated is BIM, and obviously you can use a BIM viewer to view the BIM data, but also to view the other OT and IT data that are linked to the BIM data in 3D. But that could be also classic dashboards and so on. Now that we have talked about reason of adopting technical reasons for adopting a digital twin, let's talk about benefits why adopting the digital twin. And a digital twin can support the real estate value chain. It's not just for one type of person, okay? It's for all the stakeholders, notably of the operation and maintenance phase. Anyone, all the stakeholders, whatever is an asset manager, a property manager, a facility manager, the tenant, the person taking care of energy savings, they need data. They need information about the building, and they may need also to pilot the building in order to achieve goals. Okay, so they all need this type of digital twin to achieve the goals that has been set by the company. On the build phase, this type of digital twin can be used also to make commissioning of the BMS of the different silos, and of course can be used to start to create the as-built documentation that will be then reused during the operation and maintenance phase. One word about the commissioning, because that is a very good experience we had with our customers, is that who knows about the BMS commissioning? Almost no one. The digital twin, because it needs the data, will be able to inform you of the stage of installation, of implementation of the BMS or another silo. Okay, and that is quite interesting when we know all the difficulties that this market has around the commissioning of the different silos. To summarize what I've said, a multi-system digital twin brings value at the data management layer. It's a single source of truth of all types of data: spatial data, static, and live data. It's a data ontology fabric. It enables semantic interoperability between the different silos. It enables inter-silos orchestration to create connected experience. It enables to reduce the cost because you're going to simplify your IT architecture of your building with less connectors, less developments, less cost in terms of maintenance and run. It's much greener than having more and more equipments installed in the building. Is what we see in many buildings. We can see that we have 2 or 3 times the same data coming from 2 or 3 different silos. Here, the idea is to capitalize on the data that exists and reuse them and send it to all the applications that need this specific data. And so at the end, you get much greener and you reduce the cost too. And it must be future-proof, meaning that if you change something, it's not going to break your IT architecture. Like, you're changing of CMMS, and the CMMS was connected to 5 silos. Well, then you need to recreate these 5 connectors, and that has a cost, of course. So it's not really future-proof. And multi-system digital twin is a future-proof system. The other value is on the data visualization. Of course, you understood that spatial data enable you to visualize all the data in the 3D, and that contextualize all the information. And that is going to improve collaboration between the people, facilitate the transactions, reduce risk, optimize maintenance, optimize the space, and will enable to save energy, maybe not the way you think. Because all what we see on the market today mostly is to say, is the number of consumed in terms of energy on this building, but it doesn't really enable you to pilot in order to achieve goals. And multi-system digital twin is bidirectional, so it should be able to pilot equipments to achieve goals. Other benefits of the digital twin, I'm going to explain that through a customer example. I cannot say the name of this customer. I'm sorry about that. But what I can tell you is that it's a 70,000 square meter office building located in Paris, in France. And what you can see here is the number of silos that was integrated for this building. Okay, so of course you have the BIM models that gives you the spatial description of the building. You have the BMS supervision. You have the room controllers, parking sensors, and CMMS, and tenant experience app, and their Power BI, and so on and so on, and BIM for operation and maintenance hypervision. Okay, so that all the silos that are need to be interconnected. The first results we have seen is, and that was something we haven't thought about, it is that the digital twin can be used as a commission tool, as I said before. The CMMS system, so the maintenance system, has been set up automatically by the digital twin. So instead of having someone to manually integrate the CMMS, describe the building into the CMMS, it is the digital twin that push that information, so that referential, that description, to the CMMS. And that is a very good cost, good savings, I would say. Sorry. Another thing is that during the run, the digital twin has been able to push that description that has changed to 3 different types of silos. Okay, and so instead of going to each of the silos to update the description because you remove a wall or you added a wall, for instance, you had only to do it once inside the digital twin, and the digital twin pushed that information through its API to the applications and system. We have done that also with the room controllers, so that automatically you don't need anyone that to come on site to reconfigure the room controllers and so on. That is automatically done with the CMMS and with the tenant experience app automatically every time there is a change. So one change enables to cut the cost of implementing that changes on the different silos. Just thanks to those type of return investment, the payback is 2 years. And we are not talking about the other payback, like enabling cross silos indicators that were not possible before. That is going to give a new vision for improving the piloting of the building, understand better how the building is used, and so on. A good example here is that usually all indicators are based on one silo, but doesn't take into consideration how the building is used. But if I tell you that today the building has consumed X, and it's it's a lot compared to usual. And on the same side, at the same time, you know that this building has been used only at 20% of its capacity. You can, by crossing this data, you can really understand that there is something that's not running correctly. Okay, it's not possible to consume so much with so many so little people in the building. Okay, so crossing information like how people use the building with other information will enable you to really understand much more how the building behaves, how the building is used, why you're consuming more energy, why these type of equipments are requiring more maintenance than the others, and so on and so on and so on. So you really need to cross data to better understand what's going on in your building. Two last slide, and then we move to the Q&A. Here is the architecture we have implemented on this building. So what you can see is on the bottom, the OT systems, so room controllers, BMS supervision, and parking sensors. And on the top, you can see the different applications: tenant app, CMMS, BIM for OEM, and Power BI. And in between, of course, the digital twin that enables to interconnect the different systems and fix these semantic interoperability issues. Okay. What would have happened without this? Well, you will have to create much more connectors. Here we have 1, 2, 3, 7 connectors. As a minimum here, to do the same services than what they want today, you will need 13 connectors. Means an higher implementation cost, but also higher update and maintenance cost during the duration, the lifetime of the building. So let me end on this. And I hope it was quite clear. Let's move to the Q&A session.
Great, thank you, Sebastian. And as Sebastian said, let's open up with some questions. If anyone wants to have anything clarified or to dig into some of these different points that have been raised, where I think was a fantastically in-depth presentation here. So please feel free. If you type them in, I'll be able to take them on here, and we can get going with some questions. Also, Sebastian, I know you've published an article on LinkedIn, right? Which I think we can see there, right? If anyone wants some information in English. Is that correct? Hi, Sebastian. I don't know if you've muted.
Sorry.
No problem.
No, sorry. What did you say?
No, just that you've posted an article online. I think it's on LinkedIn, right? So if, I will encourage people to go and read that as well, and we can put a link to that in the video recording, which will be up tomorrow. I mean, I think I thought it was really interesting. I mean, some of the points that I picked out, which you know, sort of clarified things to me. I mean, well, first of all, like about this concept of using the digital twin to inform about commissioning, or at least use as commissioning tool. I think that's super interesting. I mean, maybe you could elaborate that on a little bit, like, because, for example, I know that this is an issue. A lot of systems do not get commissioned properly, and therefore, you know, even when they're new, they're not as efficient as they can be. So I'm just interested, just a little bit of, maybe you could talk just quickly, like how does the digital twin understand that something hasn't been commissioned properly?
Okay, you know, digital twin is nothing without the data. Okay, so of course you need to collect the data, and the first thing is going to tell you is you have the project manager that says, well, you can go because the BMS has been and the room controllers has been implemented on all floors. So now you can move on the digital twin project. Okay, fine. And we scan the network, and we start collecting the data. And we see that we don't have all the data. And I'm telling you about a true story here. And you see that, for instance, it's only half of the job that has been really done as of today. Okay, but of course you have a different information between the BMS integrator providing information to the project manager and ourselves that use the data. Okay, the project manager doesn't use the BMS data, so it doesn't know anything about what's going on really. On our side, as we need the data, we're going to be able to know if the commissioning has been, well, if the implementation has been done totally. This is point number one. And secondly, we need to use the data. And so our applications, or the applications that are going to consume this data, will see if the data is of quality, is correct or not. Okay. If not, the application is not going to deliver the value. How can I say this? The service won't be delivered the right way, and so it gives you an information as there is a quality issue somewhere. Okay, that's the way digital twin help in the commissioning process.
Okay, got it. Thank you. A question that's come in for you here, Sebastian. Can you confirm that in your architecture you store the data?
Yes, we store the data for a few days, a few weeks, or a few months, but not for years. If we want to keep the data for years for future analytics and AI system, which is a very good idea, by the way, we're going to connect a database in which we're going to store all the data, and the digital twin system will enable to go and collect the data required by an analytics system that is based on historical data. Okay.
So that kind of almost then just becomes another connector in that system diagram that you showed there.
Exactly, it's one more connector, and why we don't keep all the data into the digital twin, because the digital twin needs to run in real time, and so it needs to go fast. And to fix that issue, we have developed specific database data hub that is running in RAM directly. So RAM is a very high cost, as you know. So to limit the cost of the servers, we are better to reduce the RAM that is required and install another classic database connected to the digital twin.
Okay, yeah, that makes sense. Makes sense. Some other things that I picked out, which again I think really interesting, like this relationship between the BIM and the digital twin that you create. So, for example, you mentioned at one point that the BIM is sort of the data, or can be the data ontology fabric. I thought that was interesting. I mean, is that you see that sort of BIM as like the delivery mechanism for creating the ontology in this with your architecture?
Yes, exactly. So if I can try to give an image here, and obviously that's the way it works too. The first type of data we integrate into our digital twin is the BIM data, okay, coming from the BIM files. There is not just one file, but several files. And these create a kind of skeleton of the database, right? And notably the graph I've shown you, because BIM data is a graph data, okay? Is a semantic graph, exactly. And so you have already that structure, okay, in your created directly in your database. Of course, you must use a database that is able to digest graph data. If not, you are using the graph. And then we're going to connect the OT and IT data to the specific point of this graph, okay? So if you remember, the graph was going up to an endpoint, like temperature. So this represents the real temperature in the physical world. And so I'm going to say I'm going to create a link between the physical world of this specific equipment that is in a specific room, and say, when you generate data, you send this data into the graph at this specific point. So now I know that this 21 temperature is coming from room 202 that is close to this and this room belonging to the floor number 2, and so on and so on. So it generates automatically the entire ontology that applications needs to consume the data. That's the way it works. I hope the image was good enough. I don't know.
No, absolutely. So and in effect, you're then, I guess, sort of in my layman terms, but you're like augmenting that very sort of rich BIM data with, you know, the information that's coming from the room controller or the sensor and then that's what creates the real-time information that is then contextualized by the BIM. So for example, you know exactly where that room controller is in the building.
Exactly.
And I think one of my other question then is, again, it's sort of a bit more general, but do you think that there is a perception that BIM has just been for design and build? Because I know in one of the diagrams you say that, you know, BIM for O&M. I mean, do you get a sense that people are more interested now in BIM for operation and maintenance? I mean, they don't just see it now as something for the design and build phase.
It's coming, but it's still far. But yes, it's coming. I can say that, you know, you have the customers that have already invested in the BIM, and obviously BIM for design and construction is a very high cost process. And of course they say, okay, I've got a great asset that is a BIM file, and maybe I can capitalize on that during the operation and maintenance phase. So you have this type of customer that are really looking at using BIM during the operation and maintenance phase. And then you have the rest of the market that says, well, BIM cannot be applied to existing buildings because the cost is too high, which is not our vision, because the BIM, the cost of the BIM creation on an existing building is only a very small portion of applying BIM during the design construction phase. Because during design construction phase, you have people that are going to spend a lot of time thinking about the project. They are going to create a project, which is much more time consuming than just replicate something that exists. And notably exists usually from 2D plans and DWG and AutoCAD files. And it's so easy to use that information and create a very low-cost BIM file that is enough to implement this type of digital twin strategy. We have customers with which we have charged not more than 10 cents a square meter to create their BIM file, which is nothing compared to the cost you can see on the design and construction phase. It's because obviously I may have a BIM file that is just, I've got floors, I've got the rooms on my floors, and I've got equipment inside my rooms. Is all what I need, nothing else. It's simple, very, very simple BIM. It's another way to use BIM. But BIM is, as I said, a graph database, okay? And I can digitalize with a database. When 2D drawings are drawings, they are not a database. So it's very difficult to digitalize from a drawing. That's the point, and that is the revolution of BIM. It's not just 2D to 3D, it's no database and database.
Yeah, and there's some excellent points there. I would actually like to dig into it, but we've had some questions come in, so I better, given we don't have much time left, I should take these questions. Sure. In your experience, what is the biggest barrier to buildings and building portfolios adopting digital twins? And what type of building portfolio is feasible for digital twin adoption right now, in your opinion? So,
in our opinion, the market starts with large buildings. Could be commercial buildings, or it could be industrial buildings. We have both customers on our side. It's easier today to convince people to implement this type of technology on new buildings than existing ones. And the best end customer is the owner and not the developer at this stage.
No, okay. Yeah, they see more, there's more value in it for them than there is for the developer.
Exactly.
Yeah, no, great point. There's a question here. I don't know if this is one you can answer on the webinar, but I'll ask it, and then maybe they can follow up by email if you can't give an answer. But what does a digital twin cost for a 20,000 square meter building with the functionality laid out in this presentation? Is there sort of a rough estimate? Or?
Yeah, I would say between €1 per square meter to 10, 20 euros per square meters. Okay. It depends on the information system that you want to create. Okay, do you want to create an information system with 3 silos or 20 silos? How many applications are going to consume the data? Going to have a building with 5 services for the tenants, or 50 services for the tenant? It really depends on this. It's mainly based on the size of the building, the number of endpoints, and the number of silos and services you are implementing. So it could be low cost, like €1, to very high cost, like 20 euros per square meter.
Depending on complexity, yeah.
Complexity and number of services you want.
Yeah. Another question here. Can BIM data then be used to determine the operational status of a device or equipment component, i.e. if it requires routine maintenance or is not functioning properly?
So what do you mean by operational status of a device? Um,
Yeah, good question. I think basically how the device is functioning.
okay, all right.
Does it need to be maintained? Is there a problem with it?
Okay. Well, if the data exists, so it means if the data is generated by the equipment and the data is available through protocols or APIs, then we can collect it and react on it. Okay. But the information must exist somewhere. The BIM is not going to fix the issue. The digital twin is not going to fix the issue. The digital twin is there to collect the data, structure the data, and enrich the data with the ontology, and then provide the data to applications that are going to consume it. And one of the service of this application could be, oh, there is an issue on this equipment. Okay, but of course, the data must exist, or because I'm doing cross analysis, I'm going to find out that potentially there is an issue on this equipment, or an issue will come in the next days or month. Okay, it's about predictive maintenance, obviously. But if I'm starting to cross data coming from my CMMS and my equipments, I'm going to find patterns. And with these patterns, I will be able to make predictive maintenance action, which is quite difficult to do when you base your predictive maintenance on just one silo. You really need to cross the data to get there. It's what I said. All what we can see usually doesn't take into account the way we use the building. Okay, if I take an example, simple example like a meeting room. Okay, let's say that there is a very, very nice meeting room. Everyone wants to get to use it. Okay, so this one is going to be used 100% of the time, every day, and so on. Guess what? Of course, this room will have much more issues because the systems are more used. Okay. So if I got this information, how this room is used, and at the same time I get information from the systems, alerts, alarms, these type of things, and at the same time I've got the number of tickets per family from the CMMS system, and I cross that, then I will be able to do predictive maintenance.
Yeah, good example. Yeah, thanks. Final question here. I mean, one from me really was, if you, let's say someone out there is listening who is an existing building or portfolio, like where do you start with this? Like if you want to begin a digital twin project, I don't know, maybe you have some BIM model or you don't, like what would you recommend is the easiest first step?
First step is I will really suggest to the customers to do a proof of concept for this type of solutions today, because it's quite easy to see 3D representations and with data inside that moves, that change colors, and so on. That one thing, but obviously the most important part is the data management and how you're going to implement your project to be successful. And the only way to learn is go with a proof of concept. So I would suggest anyone that wants to move that way to start with a proof of concept, and then obviously a lot. I don't want to say a lot here, but some good job has to be done on the BIM. Okay, if the BIM is well done, I'm not talking about the fact that there is the right colors and so on. I'm talking about really the data of the BIM. If the data are well structured, then it will be much easier to implement this type of products at a lower cost. So I will recommend to spend a bit more time on the BIM and talk and include in the conversation the different stakeholders of the project, like the BMS integrator, for instance, that has its own needs to integrate this system, but you're going to ask him some information also. So you know, you need to find a way to collaborate, and everyone has to find what he needs to deliver its job. And so what we are used to do is really to have everyone around the table discuss and agree on the way we're going to manage the project, the delivery of each silos, so that it's easier to implement the product.
Right. Thank you for that. And yes, of course, Sebastian, I think we've reached the end now. So
okay, sorry.
Thank you very much for your time today. I thought that was a fascinating presentation, really interesting. I definitely learned more about digital twins today. So thank you for that. And thank you to everyone out there for listening.
Thank you, everyone. Thank you, James, for the invitation.
You're very welcome. And as I said, just before we go, everybody, we are recording this. So check your emails tomorrow. You'll get a message with the link to the recording. Please share it with your colleagues. And also we will link to Sebastian's article there, Why Should I Adopt the Digital Twin Model Across My Building Portfolio? So you'll be able to read that as well. Links up on LinkedIn. Thanks again for listening. Appreciate it. And look forward to next month's webinar. Thanks, guys. Bye-bye.
Thank you. Bye-bye.